Hi everybody, welcome to another video in Gaussian Algebra, section 2.5. This is going to be a very long section. Transformations of graphs. So before we study about transformations of graphs, just go over some basic function. This is the identity function, which is y equal to f, or f of x equal to x. So f of x equal to x. Quadratic function is y equal to, or just say x squared. Either we say y equal to or f of x equal to, that's still a function. Cubic function, x cubed square root cube root function, and absolute value function. Right. Identity function is just the diagonal line. X. Notice the common characteristic of all this function. All of them have go to the point 0, 0. And actually all of them go to the point 1, 1. X equal to 1, y equal to 1 as well. Because x equal to y equal to x, so x is 2, y is 2, so that's why we have the diagonal. Quadratic function is parabola. We studied that in the next chapter. X cubed, like that. Square root of x, cube root of x, absolute value of x. All of them go to the point 0, 0 and 1, 1. And also note that this is x to the first power, so this one is an odd function. So this is an odd function, this is an odd function, and this is also an odd function. This is an even function. That is neither, because there's no symmetry, no spatial symmetry here, and absolute values is an even function, so symmetric on the y equal to x. Odd function, symmetric on the origin. Right, so with that, go to the first transformation is the vertical and horizontal shifts. So shifts, or we call translation, meaning that we just move the graph away. By the way, we study more in general concept. We not just focus on what the graph is going to be, because the calculator is right there, so we can check it, but the concept here is a lot more important. So here, vertical and horizontal shift or translations, meaning that we just move the graph from one place to another. Right. So consider the graph of the following function. Consider the graph of f of x. The graph of this following function will be just related to f of x as follows. If we add a number or subtract a number to a function, we're going to go up or down that much unit. When the plus opposite number go up, subtract goes down. Now, if we, instead of adding a number outside of y equal to f of x, we're adding inside of the parentheses, meaning replace to x, or inside, we're going to go right or left. And notice that is plus is up, and minus h is to the right. We'll talk about that more in a minute, just for now. Right, now let's just use a basic function and sketch x squared plus 2. So basically we just have x squared plus 2. First we have x squared, just going to graph x squared this is the basic graph. So we start with the basic graph or basic function y equal to x squared. And then after that, we're just going to plus 2 into it. And if we plus 2, we're going to move the graph 2 units up. So pretty much if we plus 2 here, we add the y values by 2. Therefore, we move the graph up 2 units. So 2 units up. Or we just add 2 to y values. So this point is 0, 0, 2 unit up. This point 1, 1, 2 unit up. This point 2 unit up. And we have the graph. This is y equal to x squared plus 2. Right, simple enough. Now, if we want to graph on the calculator x squared, I just type xx, that's of course x squared, or just x squared. The other x squared plus 2. Because if we're going to graph like this, we don't really see which one which. Because graph the first and then the second. But I can just, if you want to change the parent, move all the way to the left and change this to hit enter and change to something else. Like that will be the border graph. There. Right. So plus 2 unit up. That's easy. Next, obviously here we have the basic of x cubed. And now we have the minus 1. So minus 1 here, we just minus all the y values, subtract 1, or we move 1 unit down. Subtract 2, subtract 1. To the y values. So we start with x cubed. Right. And now we just move everything down 1 unit. 0, 0 move down here. That point move here. That point moves here. And we have the graph. So this is y equal to x cubed minus 1. Right, so simple enough. Now, we have, instead of the number added on the last the function, we add the inside of the function. By that I mean inside the parentheses. So here we have the basic function of y equal to absolute value of x. What we do now, we do not add the number on the outside, we add the number inside of the parentheses, and what we add is the minus 1. So let's see what will be the graph. By the way, absolute values is under math. Go to the second tab, numerical, absolute values of x. Yeah, because that's the v. Right. Now, what if we want absolute value of x minus 1? Let's change this pattern to a border graph. So let's move 1 unit to the right. If we move 1 unit to the right, we're just going to add 1 to x values. right? So I have a v for absolute value of x. I will move 1 unit to the right, so 1 unit to the right, 1 unit to the right. Right. Now, before we go further into the question, then if you wonder, does that look a little bit backward? If that is the case, then yeah, you are correct. Notice that we have the x-axis horizontally, the positive sign on the right, negative on the left, the y-axis positive up and negative is down. Right, so here when we plus, which is a positive, so go up, and negative go down, so that makes sense. However, on the x-axis it tends to be backward. This is -1, but we move to the right, where the x-axis normally, the x-axis on the right side is positive, the left side is negative, but this time it's -1, we actually go to the right. Well, a way to do this is to consider a very simple example. So instead of absolute values, just look at x. Let's say if I just replace x by -1 here, in that case, that of course can either go down or, but notice that if I write like that, I can also say by +1 on both sides, we have y +1. So the x values now is a +1 here, but on the other side, meaning that if we want to keep the x, the positive signs on this side, so this is, we do have +1, so it still move to the right. Yeah, the x values still +1. So because usually the functions y equal to something, if we add into y at the end, that's the same, nothing. But if we replace into x, it's going to be in the reverse manner. I'm going to write that down in a minute. First, let's just go to the next one. This one, the basic function, of course, is the square root of x. But now notice that the +1 here is inside the square root, not on the outside. So this has +1. And so let's see. Square root is here, so second square root of x, square root of x +1. Let's change this to the border graph. x squared +1. So 1 unit left. Once again, this time it kind of, if we move to the left, we subtract 1, 2, the x values. Once again, negative this time for x go to the right, and positive go to the left. Right, so we have to write a note here. Okay, sorry, draw the graph first. Square of x, and then move that to the right, the left 1 unit, sorry. Right, so that's what we have. So notice that whatever works for the y values work for x, but in the reverse manner. And one thing I want to note, another thing I want to note is that this one we just add on the outside of the function. By that, for example, if we have square root of x, for example, if I add the number +5, that is on the outside of the function. And if I +2 like this, it is inside of the square root, right? So you can distinguish those two, right? And the one outside here will affect the y values, meaning affect the graph vertically. The two inside will affect the graph horizontally, meaning affect the x values. But whatever inside, it will affect the x values in a reverse manner. And that is very important. We'll see that in the rest of the section. But here out, write out the note. If it is on the outside of the function, it will affect the graph vertically or affect the y values. Now, if it is inside, like by that I mean outside, that is inside. If it is inside, it will affect the graph, affect the x values, that means horizontally. But here the important thing, it's only affect the graph horizontally, but in the reverse manner. Right. So that's the important note of the whole section. Outside affect graph vertically, or the y values. Inside affect the graph horizontally, or the x values, but in the reverse manner. So if you think that is the positive x is on the right side, negative on the left side, transformation that have to be reversed. Right. Now, more type of transformation. So earlier we have translation or shifts, meaning the graph just moving around, do not change the shape. This will change the shape. Consider the graph of the following function of the graph of f of x. The graphs of the following function are related to f of x as follows. Notice the 8 here is on the outside of the function, right? So that is vertically because it is on the outside. Sorry, switch different color. Try to keep the color code here. So vertically because it is on the outside, and this is b is from the inside, so it will affect the graph horizontally. So outside vertically, inside horizontally. That's what we have. Now, in terms of stretching and shrinking, as you see, they work in the reverse manner. If it's bigger than 1 is stretch, if it's less than between 0 and 1 is shrink. Well, opposite reverse manner in the horizontally. That's exactly like what we have in the note, right? Whatever it affects the x values, whatever it affects the graph horizontally, it will be in the reverse manner as we do on the y values or vertically, right? Actually, we don't even need to know if it's stretch or shrink. What's more important is we know that's from the outside or from the inside. So from the outside here, pretty much we just multiply it. So here we just say multiply y values by a, and here it is inside, it had to be in the reverse manner. So instead of multiply, it is divided by divide y values by b. Right, so it works in the reverse manner. Now, in terms of stretching and shrinking, that's very easy. Think of a number, a positive number, 5. If you multiply by 2, or a number that is bigger than 1, the number get bigger. And if it get bigger, that means stretch. So multiply by a number that is bigger than 1, we make it bigger, so we stretch. If we multiply by a number that is less than 1, for example 0.2, we get a smaller number. So multiply by a smaller number, we make it shrink. And likewise, the other one is works in the opposite direction. If we think if we have a number divided by a number that's bigger than 1, you get smaller. So bottom line, if we get a smaller number, it's going to be shrink. If we get a bigger number, it's going to stretch. And then horizontally, vertically, we define based on if it is inside or if it is outside. Right, simple enough. And let's look at this. This is the basic graph of y equal to x squared. That's what we have. So x squared is a parabola. Now, we have a 2. So what do we do then? A 2 here is outside of the square, right? Because we have a square. If the 2 is inside, it will be here. But this time the 2 is on the outside of the square. So it is on the outside. So outside will affect the graph vertically. So here we just multiply the y values by 2. If we multiply a number by 2, if we have a positive number multiplied by 2, we're going to make the graph bigger, or make the number bigger, therefore stretch. Here we just say stretch vertically by 2. Right? So now, or we just multiply all the y values by 2. The y values is the height of the function. So say this point, the y values is equal to 0. 0 times 2, still 0. Now this point, y value is equal to 1 multiplied by 2, it's going to be 2. So this height is double. Let's say we have this is the y values. It's just going to double because we multiply by 2. So basically we have the graph going like this. So you see, we just stretch the graph vertically, and that's what we have. So let's say we have x squared, and then 2x squared, right, x squared, and then we stretch it vertically. Yeah. Right. Next, we have the basic graph. Absolute value of x. Just say y equal to absolute value of x. That is a v. Next, obviously we're going to put the 3 multiply to x, but whenever we do for x, we have to do that in the reverse manner. So in this case, instead of multiplying, it actually multiply 2, right? Multiply x by 3, but remember it have to be in the reverse manner. So divide x values by 3. I'm sorry, this should be the x values. Because it is inside, it works horizontally, meaning affect the x values. So we divide x values by 3. Now, if we get a number divide by 3, we get a smaller number, right? Because it's smaller, it's going to shrink by a factor of 3. Or we divide x values by 3. Right. This point, x equal to 0 divided by 3. 3 divided by 0 is still 3. Sorry, 0 divided by 3 is 0. Next, this point, x values is equal to 3. Yeah, x is equal to 3. Divided by 3 is 1. So instead of that point, we move there. Remember, x values is the horizontal distance. Just cut that in 1/3 of that. So what the graph we have is this v. So what we have is the graph, just shrink it horizontally, just push this graph horizontally. We're going to have y equal to absolute value of 3x. Right. Next, this is obviously a square root. So the basic graph is the square root. Next, we have 1/2 multiplied to x. So if it's multiplied to x, if it works for x or inside, it will affect the graph in a reverse manner. So instead of multiply by x, we actually have to divide by 1/2. However, divide by 1/2 is like multiply by 2. Now, if we multiply a number by 2, we're going to make, if it's positive, we're going to make it bigger. Think about this only when we think about the positive number. We'll talk about shrinking and stretching. Multiply by 2, so we get bigger, therefore stretch. So stretch by a factor of 2, and a particular stretch horizontally. Yeah, I should say a shrink horizontally. Right. Now we have the square root. Square 4 is 2, so yeah, it's 3 points. So this problem we just going to sketch. We don't actually graph, because graph usually have to be a little more accurate. We have to plot the points also, but we're not doing that. Just sketch. Just get the idea, right? So multiply the x values by 2. So if this is 0 times 2 is still 0. 1 times 2 is 2. And then whatever that is, the distance, just going to double. So the graph here is going like that. So as you see, we're going to stretch it horizontally. But let's just graph that function, right? Square root of x, and then square root, just delete that, square root of 1/2 x. There. Right, so we have x, and then we will stretch it horizontally. Right. One more type of transformation. So this is vertical and horizontal shrinking and stretching. Like I said, don't get too hung up with shrinking or stretching. In general, in life, when we stretch, we make it bigger. Shrink, make it smaller. And outside, it will affect the graph vertically. Inside, it will affect the graph horizontally, but in the reverse manner. So instead of multiply, it's going to be divide. Right. The next one we have reflection across the x-axis, or reflection across the y-axis, or reflection vertically, or reflection horizontally. Once again, if it is on the outside, just try to keep the color code here. Right. If it is outside, it will affect the graph vertically. If it is inside, it will affect the graph horizontally. And think about the reflection here. We mean if it reflect across the x, think about the reflection like this. That is across the x-axis, or vertically reflected. And reflect across the y-axis. Think about this as so reflect across the y-axis. So that reflect horizontally, vertically, horizontally. Right. Now let's look at the graph of negative x squared. Negative x squared. The basic graph is x squared and then we just throw in the negative. So meaning that all the y values multiplied by -1, if you will. So this is just flip it vertically, just reflect vertically. So we have x squared and then reflect vertically. Yeah, just flip it upside down, and yeah, that's all we do. So pretty much all the y values multiplied by -1. 1 times -1 is -1. 4 times -1 is -4, and so on. So that's why the graph flip it vertically. Right. Next one. So the next one we have square root. So the basic is y equal to square root of x. So we have the basic function and then we'll throw in the negative. Since it is inside the square root, it will reflect horizontally. So meaning pretty much we divide, remember inside will affect the graph horizontally on x values, but in reverse manner. So here we multiply by -1, here we divide by -1, but regardless, divide by -1 or multiply by -1, in this case they are the same. So y divided by 0 divided by -1 is 0, 1 divided by -1 is -1. So the graph will flip horizontally. So to put all of that together, I have the summary like this. Notice that the order of transformation is similar to the order of transformation is similar to the order of operation. So inside the parentheses, multiply, divide, and then add or subtract. However, a little bit important here is that we're going to multiply first, then add or subtract. Sound a little bit awkward, but we don't really have a parentheses here in the order operation. We just have inside or outside the function. So again, multiply first and then add or subtract, and then inside first and then outside. Well, that part is obvious, order operation is like that too. Inside parentheses and then outside. So we do the same thing here. Order transformation is going to be inside first and then outside. So this 2 is inside. I try to keep the color code. So inside first and then outside. Right now. So inside is horizontally, outside vertically. That makes sense. And so we multiply, divide first before add or subtract, meaning shrink, stretch, reflect before we shift. Right. Now let's combine all of that together. Let's see, we have this. So the first thing we do, when we do this problem, is determine the basic function. The basic function here is absolute value of x. So that is a v. Just and then we have a multiply by 2, and then we have the plus 1. Now, if it is order operation, we're going to add first and then multiply. But notice that in transformation, there's not really the parentheses there. Or what we just say is always multiply, divide, add, or subtract. So actually, we have to multiply first. And this is inside. So we'll instead of multiply, we have to divide x values by 2, meaning it's going to shrink, right? Divide by 2, make things smaller, therefore shrink vertically. I'm sorry, inside horizontally. And then that's plus 1 is 1 unit to the left. Right, so that's what we do. First, we make it shrink. 0 divided by 2 is 0. 2 divided by 0 is 1. Negative 2 divided by 2, I'm sorry, 2 divided by 2 is 1. Negative 2 divided by 2 is negative 1. So 4 divided by negative 4 divided by 2 is negative 2. So pretty much we have the graph here. And finally, we move 1 unit to the left. One unit to the left. Yeah, so that is the first step. This is the second step. And here we have the final is y equal to absolute value of 2, x plus 1. If we want to graph, math, numerical, absolute value 2 times x plus 1. Okay, I'm glad I checked that to the left, meaning that left side. Yeah, I just moved to the right. Right. Glad I got that. Yeah, like I said, my concept is perfect, but the execution is terrible. Remember, 1 unit to the left. Let's be careful with that. So that is the final graph. Right. Of course, if we want to compare to the absolute value of x, just going to say it, absolute value of x, I just change the parent, make it lighter graph, about dotted. Yeah, that will do. That doesn't do it. Okay. Just make this one darker. Yeah, so that's what we have. By the way, if you wanted to look the scale, you can hit zoom number 5. It will do a much better scale. Right, so that's what we have. Right, next we have this. So obviously we have the square, so that we start with the basic. And then we have quite a few things. The negative, the 2, the negative, and then the 2, and the negative 1, and the plus 2. So all different things. Let me just write out. That negative on the outside is on the outside, right? Reflect outside vertically. The 2 on the outside, multiply to it, so multiply y values by 2. If multiplied by 2, it's going to stretch because we make it bigger. So that take care of it. The plus 1, sorry, the minus 1 is 1 unit to the right. Because that is inside. And the plus 2, 2 unit up. Right, so we determined that those are the transformation that we're dealing with. But the question is, in what order though? Remember, this is always inside and then outside, stretching, shrinking, reflection before shifting. So, inside and then outside. So this is the first thing we do. This is inside. And then multiply, divide. Before add or subtract this, we add 2. So we're going to do in that order. First we have x squared. Next, multiply y values by 2 and then reflect. So we're going to have kind of that. Stretch and then reflect. So that's number 2, and then 2 unit up, just move everything up 2 unit. So on the final graph, we say this is negative 2, x minus 1 square plus 2. Right, let's verify that. First we have x squared, the basic graph, and after all of the transformation end up with negative 2, x minus 1 square plus 2. So and I forgot to move 1 unit to the left. with all the color code that I actually prepared for another page. Alright, let's do this again carefully. The basic graph, x squared, and then the negative reflect vertically. I said I got all the concept down perfectly. I just execute a little bit off. The 2 multiply y values by 2. Meaning we stretch it by 2. And then there's a minus 1. 1 unit to the right. And then plus 2. 2 unit up. Right? The order, do this first. Those, and then that. Right. So that's the idea. X squared right, 1, move 1 unit to the right, right, this way. Right, put a check, and then reflect, and then multiply by 2, or multiply by 2, reflect. This we can do at the same time because we just multiply by number. So I stretch all the y values multiply by 2. 0 times 2 is 0. 1 times 2 is 2. So I'm going to stretch. And then reflect. So put the check mark there. We're done. And then finally move 2 units up. Yeah. So I have to be very careful with this. Right, so this is negative 2 x minus 1 square plus 2. Right, so I said just write out all the transformation, and then we just go ahead and do the transformation. Make sure the order have to check. Right. Next we have the graph of y equal to 1 minus x. Now it look obvious, it look easy, was just that. However, this is a tricky one. We have to scramble a little bit. So what do we need to? Right. Now, this actually is negative x plus 1. Remember, it's always x minus something or x plus something. So that's first thing we do. Negative x plus 1, which is equivalent to this. And then we can write factor to negative x minus 1. So in fact, this is what we have. Have a negative sign. With, of course, reflect the graph horizontally because it is inside. And a minus 1 unit to the right. And the basic function y equal to square root of x. That's what we start with. Right. Now important is what order do we do this in. So it is inside, so affect the graph horizontally, so both of them horizontally. Now within the inside or within the outside, always multiply, divide, and then add or subtract. So we're going to multiply the negative first, therefore we're going to reflect first, and then we move. Right, the basic y equal to square root of x. and then horizontally reflect, so just flip it, right side left. And after that, one unit to the right, so that point moves here, point move here, so that is y equal to 1 minus x. Right, just graph, see if it works. Square root of x square root of 1 minus x. So I have square root of x, and then flip it and move one unit to the right. Right, so that is the combination of transformation here. Note that, we just write out the basic graph, and then write out all the transformation, and then determine the order, and then make sure you do all of those transformation. Right. Now, so those are the problem. We have the basic graph. We can test this problem. We cannot test them, so have to be extra careful. Okay. So the graph of y equal f of x is given. So the graph looks like that. What we have here is multiply by 2. If we multiply like 2 on the outside of f of x, therefore that we multiply y values by 2. That means it's going to stretch. So I'll determine the order of the operation later. And then there's the minus 1. So this is 1 unit to the right. And the plus 1 here. 1 unit up, because that's on the outside of the function. Right. So we have the function. Those are the transformation that we have. But in what order though? Remember, it's inside and then outside, multiply, divide, and then add or subtract. So inside have to be first, 1 unit to the right. That's the first thing we do. And then on the outside, multiply the y values by 2. So that's stretching, multiply first, and then add or subtract. So that is the order that we'll graph it. So everything 1 unit to the right. So 1 unit to the right. Next, multiply the y value by 2. So we stretch it. This y value is equal to 1 multiplied by 2. Y value is equal to 1 multiplied by 2. We're just going to grab the point. And this point multiplied by 2, negative 1 times 2 is negative 2. So we have to stretch. And then just move 1 unit up. So at the end, this is what we have. This is y equal to 2f of x minus 1 plus 1. Right. So so now we can sketch the graph based on the function. Now let's say if we don't have it, we don't have the function, we have the graph. How do we write the function? Right. So first, this look like the graph of x squared. So we have the basic function x squared. But what do we have? X squared open up, right? So this is reflect. So we have reflection vertically. So let's make it upside down. And then we actually move original 0, 0, the vertex here. So 2 units to the right. And after that, 3 units up. So those are the transformation that we need. How do we put in the function? So just put something like y equal to x squared. Right, now, if we're going to flip it vertically, we're going to need the minus on the outside. If we move things 2 units to the right, have to subtract 2. And if we move up 3 units, it's going to be plus 3. Right, now let's graph that. This guy we just graph one function, x squared x minus 2 square plus 3. Yeah, that look right. Right, next. This is the shape of the V, so that is the basic graph of absolute value of x. It does reflect vertically. But at the point 0, 0, it moves 1 unit to the left. And then 2 units up. So we construct a function y and then absolute value of x. We might add something here. Right, reflect vertically. So it's going to be with the minus 1 unit to the left with plus 1 and 2 units up plus 2. Right, let's graph that. Negative absolute value of x plus 1 plus 2. Right, so that's about right. If you want to zoom in, yeah, that works. Right, next, what we have here is the shape of the square root. Right, but square root goes like that. So we have a reflect horizontally. And what else? If it is reflect horizontally, we still have some transformation here. 0, 0 here, right? Move 2 units to the right. And then move 2 units down. Right, so to construct that, we have y and then the square root x. That's the basic function. Right, now reflect horizontally, meaning there's the minus here. 2 units to the right, so that have to be minus 2 to x. However, we minus 2 to x, so it have to be immediately like that. And then the subtract affecting that. So it should be like that. And then 2 units down, right? Now this definitely we need to graph. Square root negative x minus 2 minus 2. Yeah, this is 2 negative 2. Of course, we can distribute the negative. We can also say y equal to minus x negative negative. So that, or we can just say 2 minus x minus 2. Either way, one of those is the answer. Right. So we can also, like I said, have the function and then do the transformation, then do the graph. If we are given the graph, we can find the transformation. But what if we just don't want the graph or the transformation? We just want to express things verbally, just in words. How would we do? Let's say we have the graph of y equals x squared, so that's the basic graph. And then we want it vertically stretched by 2. And then shift 1 unit up. Right. So y equal to x squared. So that looks like the basic function. Right. Vertically stretch. So we don't do anything inside here. 1 unit up also affect the graph vertically. So there's nothing in the parentheses. Do not mix up. So just x in the parentheses. Right. Multiply by the factor of 2 vertically stretched by 2. So just multiply by 2. And then 1 unit up. So we have y equal to 2x squared plus 1. Now, of course, we can test them. By the way, when we're done with the graph and you want to get back to the original window, just hit zoom number 6. That gives us the standard windows, 10 by 10 each. Right, x squared, 2x squared plus 1. X squared, then we stretch by 2. Do we have 2x squared? Yeah. We stretch and then move 1 unit up. Maybe zoom number 5. Yeah. So that's what we have. Next, the graph of square root of x. So we have stretch. Horizontally reflect. So we have to throw in the negative to the x, so make it horizontally reflect, and then 2 units to the right. This is to the right, meaning equal to minus 2. But we did this many times, make sure we have to have that in. So that gives us square root of negative x minus 2, or distribute the negative. Well, I just want to give that form. Right. Square root of x and square root of negative x plus 2. Then we have square root of x and then horizontally reflect and shift 2 units to the right. Yeah, so that's what we have. Was that similar to the example we have before? Right. Now we have a piecewise function. Right. So basically we're just going to graph that and then graph this, but for the certain condition. Right. So Now that we get used to it, I'm just going to say it. For that part, just for the square root of x minus 1, it's just square root of x, 1 unit to the right. So this is square root of x minus 1. And this is for x greater than or equal to 1, so that including the 1, so this is a dot here. Right. The other one is x squared minus 2, or x squared 2 unit down. That's easy, right? I'm just going to say it. X squared 2 unit down. I'm going to run pencil for a reason here. So 2 unit down, right? So however, this one only for x less than 1. So we do not have anything on the left side of 1. And there's no equal sign here either, so we have to be an empty circle. That part of the graph. Right. So that is the graph of that piecewise function. Right, notice this part of the graph x squared minus 2 is only for x less than 1, but it doesn't have the equal to 1 either, so that will be an empty circle. And that go from 1 and then the equal sign, so that's a dot. Right. Now if you want to put this into the calculator, there's a trick for that. First we have just going to put in the parentheses, just so you get, so we have square root of x minus 1, right? Right, put that in the parentheses. But then it is for x greater than or equal to 1, so what we do, this is the trick, divide. I'm going to say x greater than or equal to 1. The greater than will be second, hit the math, where we go to test, and greater than equal to 1, right? The next one, again, I put the parentheses, x squared minus 2, and divided by x second math less than 1, right? Yeah, so it looks like that. The only problem here is the calculator does not graph the dot and an empty circle, so that's why we have to do the human interpretation, and then just have the equal sign there, that's a dot, and no equal sign, empty circle. Right, now they'll say, why did that work? Where we entered this in the calculator and it knows to graph the piecewise function. Well, the calculator does not know about the piecewise function. What it knows is that it's going to graph both of them. The condition here is this. Notice when I write something like this, if we have 5 for x, it's going to be true. If we have 0, it's going to be false. Logically, anything is true, the value is 1. Anything false, the value is 0. Now, think about that. That's the reason we write the division sign here. So, if it is true, it's going to be divided by 1. Divided by 1, it itself, so just going to graph it. Now, if it is false, it is equal to 0. Divided by 0 is undefined. And it will not graph anything that is undefined, right? Likewise, we're talking about this one. If less than 1 is true, true values is 1, divided by 1 it itself, so it will graph it. Anything bigger than 1 or equal to 1, it's going to be false. If it is false, the logic values is 0, divided by 0 is undefined. It will not graph anything that is undefined, so that's why it did not graph the part of the x squared when it's greater than 1. So that is I think is a nice trick to graph the basic function. And with that, we finish section 2.5. Thank you for watching, and see you in another video in course algebra.